This is the first section of Chapter 12, Finding Probabilities and Odds. So I got to be honest with you, one of my favorite aspects of mathematics or disciplines is probability. Um, I love studying the possibility of something happening, and probability is just one of my personal faves. So we're going to talk a little bit about of that and give you an introduction to it today. So some terms I'm going to need you to know are outcome, event, favorable outcome, sample space, and then probability itself. So outcome is just a possible result of you doing something. An event is you actually doing something, or a collection of the outcomes. Favorable is what you want to have happen when you do the event. And a sample space is just all the things that could happen during your event. So probability by mathematical formula is super simple. It's just favorable outcomes over total outcomes. So let's take a look at a specific example so that the terms, I guess, make more sense to you. So let's say you've got two dice and you decide just to roll one of them, okay? An outcome will be what will happen if you roll it. So you could get a 1, you could get a 2, a 3, a 4, a 5, or a 6, okay? The event is you actually doing the rolling. So you put the die in your hand and you roll them, and that's what happens. That's your event. Favorable is what you're hoping will happen. So maybe you're hoping for a 2 or a 7. Well, that's not going to really happen with a 7, but whatever you're hoping is going to come up when you roll the die. And then your sample space are all the possible ones. So 1, 2, 3, 4, 5, 6 is our sample space when you roll a die. And then in the yellow box, there is just a probability of you getting an even number. So a probability of you getting an even number would be your favorable outcomes, which are 2, 4, and 6, over your total outcomes, which would be 1, 2, 3, 4, 5, and 6. And then you just count those. So that would be 3 over 6, which would be 1 over 2. And that's the same probability you'd have if you were trying to get an odd number, would be 1 over 2, because you've either got evens or you've got odds. So let's talk about theoretical probability and experimental probability. Theoretical probability is the likelihood of an event occurring based on knowing all the equally likely outcomes of an experiment. Experimental probability is repeated trials of an experiment. So this sounds like really super complicated, and it's totally not, okay? One of these is probability of you thinking about it. Like, what are the possibilities mathematically could happen? You don't do anything, but you just think about it, okay? That's going to be theoretical probability. Experimental probability is based on trials. If you've ever heard of like a clinical trial, like they're trying to, maybe find an experimental drug or something by doing an experimental trial, okay? That's actually doing. So experimental probability is doing it. Theoretical probability is thinking about it. So no matter what we're going to be doing with probability, the number is always going to be a decimal or a fraction. I hate to say that, unless it's 0 or 1. But I know some of you guys don't like fractions, but fractions are our friends. So the number is always going to be between 0 or 1. And if it couldn't possibly happen, so the probability then would be 0. And then if it's absolutely 100% going to happen, then the probability is 1. And then if you've got about a half chance of it happening or not happening, kind of like rolling that die, your probability would be 0.5. Well, let's take a look at an example here. So your friend is having a wedding, and during this the meal, you can either have chicken or beef, soup or salad, and then either ice cream or cake. Okay, how many outcomes are there, and list them? And you might be thinking, well, chicken or beef, that's 1, soup or salad is 2, ice cream or cake is 3. So there's like 3 outcomes. But there's actually a lot more. Because if you choose chicken or beef, you've got 2 outcomes right there. But then you could have soup or salad. So you could have chicken and soup, chicken and salad, beef and soup, and beef and salad. And just with those options right there, you've got 4 possible outcomes. And now that we're going to add ice cream or cake to that. So when you try to calculate the outcomes, you just basically multiply your possibilities. So in your first case, you've got chicken or beef, that's 2. You've got soup or salad, that's also 2. And then either ice cream or cake, and that's 2 as well. So you're going to multiply 2 times 2 times 2. So that's going to give you 8 outcomes. So that's a total of 8 outcomes. Well, let's take a look at them, okay? So you could have chicken, soup, and a cake. You could have chicken, soup, and ice cream, chicken salad and cake, chicken salad and ice cream, beef soup and cake, beef soup and ice cream, beef salad and cake, or beef salad and ice cream. So you have 8 possibilities here. So there's 8 outcomes. Theoretical probability looks like this. Favorable outcomes over total outcomes. So as I showed you in an earlier example, what's the probability that you'd roll an even number? Our favorable ones, there are 3. My total ones that I have are 6. So it's 3 over 6, and that reduces to 1 over 2. All right, experimental probability is successes over trials. So each trial in which the event occurs is called a success. So there's a die right there. So let's actually do it. We're going to do some experimental probability here, okay? So let's just decide if we're going to roll that even number. All right, and we've got even. Now I kind of wish that I had redone this. So that's 2, holy cow, 4, and 6. Gracie, no bark. Sorry about that. So let's just do it 10 times and see what we get. We should get 1 over 2 for our theoretical probability. So if we do it 10 times, we should get evens 5 times. At least that's what we're thinking we're going to get. But let's just actually do it and see if we get 5 over 10. Okay, well, it's not working, but we'll see. Hopefully it doesn't. Okay, so we got 1 success in a trial. Let's do it again. All right, we got it again. A success in our second trial. That time we just did it and we didn't get a successful one, so that one doesn't count as a success. We didn't get it again. Yep, we got it this time. Didn't get it that time. Didn't get it that time. If we're having a rung of bad luck. Yep, we got it that time. All right. All right, here's our last chance to get the 5th one in an even. Let's see if we get it. Woohoo! We did. So we got 5 out of 10. So we did get the theoretical probability. So it matched. Yay! Let's try an example in a word problem. So I attempt 50 free throws and make 32. What's the theoretical probability if I shot 75? And how many would I make if I shot 200? Okay. So I make 32 out of 50. So that's 32 out of 50. Now I'm going to convert that to a decimal. And 32 over 50 is 0.64. So I'm going to take that 0.64 and multiply it times 75 to see how many I would get if I shot 75 of them. And 75 times 0.64 is 48. I'm going to take that same probability of 0.64 and multiply that times 200, and I get 128. So if I physically shoot the free throws, I'm doing the experimental probability, and I got 32 out of 50. I can now use that probability theoretically to calculate how many I would make if I shot 50, or if I shot 100, or I shot 75, or 200 in this example. I can use that number to calculate what's the likelihood I would do that then in other situations. All right, Barry lost his keys. Oh my gosh, Barry is always losing his keys. He decides that the living room is the most likely spot for his lost keys. What's the probability that the keys are in the living room? So the first thing we need to do is measure the living room and figure out how much we've got. 12 times 10 is 120 square feet. Now I'm going to take his house. His house is 30 feet by 25 and calculate that. 30 times 25 is 750 square feet. And then the probability are just going to be the living room over the house, because our favorable outcome is it's in the living room. The total outcomes is it being in the entire house. And 120 over 750 reduces to 4 over 25. And you can convert that to a decimal if you wish. Otherwise, I'm just going to leave it in the fraction of 4 over 25. And again, that number is between 0 and 1, so that's where a probability would come into play. All right, odds. A lot of times people screw up odds. Would be like, well, the odds of getting a heads if you roll a coin is 1 over 2, and that'd be 50%. And that's actually not correctly used. Odds, and you'll see that even the media will screw up odds. But the calculation mathematically for odds is favorable over unfavorable outcomes, and the odds against are unfavorable over favorable. So actually, the odds of rolling heads, or I'm sorry, an odds of rolling an even number when you roll a die is 3 over 3, which is 1 over 1. And the odds against rolling an even number when you roll a die is also 1 over 1, because it's 3 over 3. So let's take a look at an example here. Suppose you randomly choose a number between 1 and 10. What are the odds in favor of you choosing a multiple of 4? What are the odds against you choosing a multiple of 4? Well, the multiples of 4 between 1 and 10 are just 4 and 8. So our favorable outcomes are 4 and 8. The unfavorable outcomes are 1, 2, and 3, 5, 6, and 7, and 9 and 10. So in this case, the odds in favor of picking a multiple of 4 would be 2, because there's 2 of them, and there's 8 that are not. So this would be 2 over 8, which is 1 over 4. And then the odds against would be 4 over 1, because there are 8 against, and there are 2 that are 4. So hopefully that makes more sense. All right, so basically this is kind of your final assignment for the year, because this is the last week that we really have of school other than June 1st, June 2nd, and June 3rd. So on Thursday, I want you to do problems 1 through 8 on page 814 to 815. And yes, I know number 5 has a lot of answers to it, but I think you'll still be able to handle it. And then on Friday, I want you to do questions 9 through 17 and 19. When you've got both of those, you can send that to me in an email, and that will pretty much finish out the school year, other than you'll be taking the FastBridge assessment sometime in the following week, and then I'll have a question of the day on Wednesday, June 3rd. So I've had a lot of fun teaching you and doing these videos, and I hope they've been helpful for you. And thank you for watching.